probabilities. So yes, there are various ways of getting this information. But once we've got this information, just like with Huffman coding as well, those probabilities are used to determine the way the codes are sort of determined. The difference with the Huffman coding is that code can be determined once you know probabilities. Here, this is a slightly different order of things in that the probabilities, or rather message, is coded sort of on the fly. You've got a set of probabilities, and then the code that you actually associate with what you need to transmit is not something you can just look up. It's something that you need to work out as it goes. But the working out isn't overly complicated, I feel. But there's quite a few numbers involved, so it does require a little bit of sort of patience and practice to try and understand how it goes. Okay, so let's just go through this problem. We did go through it last week, but it's probably good to sort of get our heads in the same sort of space with this. Um, okay, so um, excuse the use of Microsoft Paint. I was a bit disappointed to hear a few years ago that Microsoft were thinking about cancelling it because it's been a sort of integral part of Windows for forever, actually. But it's still with us, so that's a good thing. Right, so we've got this is an arithmetic coding example. So what I'll do is I'll use this sort of canvas to write out what we're going through, and then I'll upload it as well so people can get a look even if without watching the videos. Okay, so we've got arithmetic coding, and we're going through an example, um, just like we did last time. So we've got probabilities. Now, it may be a help if we can sort of vary the example a little bit. So let's think of something else maybe. That's a bit. So we've got A, B, and C. Let's add another symbol there, okay? And then for the probability, so those are our symbols, okay? And then the probabilities, those will need to change because we've got 4 symbols now. Right, so uh, let's say 0.1, 0.2, 0.25, 0.3, and then what's D going to be, do you think? Well, it needs to sum to 1, doesn't it? Yeah? So we've got 0.3, 0.25, so that's 0.55, 0.65. So the last one will be 0.35, won't it? Now that might sort of make things look a bit confusing. So what I'm going to do is maybe add a 5 to this one, because it shouldn't be in an order really. So and 0.3 there. Okay. So let's put in a few lines just to separate things a bit. Okay, yes, yes. Well done, Aaron. Thank you. Yeah, I've added 5.05 to C, haven't we? So yeah, D should be 0.3. Good. Right. Okay. So now, um, as we said, the coding is dependent on the actual message to be transmitted. So we have the coding. Let's just write this here. Coding dependent on the message to be transmitted. Okay, so let's think of example. Let code to be transmitted. Okay, so let's try and work something out which is, proportional to what the probabilities we've got here. So C is going to be quite common, isn't it? And D, yeah. So maybe we want to transmit a C and a D a few times, and then maybe an A and B. So if we take, say, so we're going to transmit. Let's start with a B, and then a C, and then let's have an A, C, and a D, another D maybe. Okay, so just we don't want to do too many because it's a bit repetitive and everything. Um, all right, so we got a B, then C, and then an A. The first thing we need to do now, we could have done this in the first place, is actually arrange or determine what we might call a set of cumulative probabilities. So this can be actually done before the message is considered. So what I can do actually is probably move this, remove that, move that. Oops. Okay, so move this down, and then we can set up the cumulative probabilities first as well. Okay, so the cumulative probability table. So this is an important part of it. So ordering doesn't matter. So we can have A, B, C, and D, and then we need the lower probability and the higher one. Let's draw some lines to keep things reasonably neat. Okay, right. So if we start at the low end, so for the letter A, so these going to take values between 0 and 1. Okay, so we should see a 0 down here and a 1 up there. That's something we can write in automatically at the beginning. So we've got 0 there, and that's going up to a value 1 there. Okay, so for letter A, the max value is 0.1. So it's non-inclusive this. Okay, the lower one is included, but the upper one is like the how can I say, the as I said, yes, not including exactly 0.1. So everything up to 0.099999. Okay, so the next one, that value gets put up there, so we can put little arrows to indicate that. And then for B, we're going from 0.1 and then 0.1 plus 0.25. So it would be 0.35 there. And then, so that gets copied up to here. And then, C is 0.35 added onto that, isn't it? So that's a 0.70. And then that gets copied to this one over here. Okay. And then if we look at this, 0.70 plus 0.3 is a 1. So that's all sort of falls into place, hopefully. Okay, so this is like a table that we're going to use to work out the actual coding. Yeah, so that's a table used to table of values used to determine the message code. Okay, so right, we've got the code to be transmitted. We'll start with a B, and then it moves to a C, then an A, then a C, then a D, and then a D. So those values we need to sort of look up. These cumulative probabilities need to be looked up given the different symbols to be transmitted. So what's going to let's do a quick sketch of what's actually going to happen now. So we're going to transmit the B. Okay, and the B's got a range of 0.1 to 0.35. Then it transmits a C. The C's got a range of 0.35 to 0.70. And then we need to transmit an A, which is 0 to 1. Not 0.1, sorry. Then a C, which is the same as before, isn't it? 0.35 to 0.70, and then two Ds. So those are from 0.70 to 1. Okay, so but if we can't base our code on just these ranges. We need to modify when we work out the code. We need to say, okay, this symbol is being transmitted, but then what went before that? That it gets combined with what went before. So we start off with the range from before, and we work out a sub range from that range. Okay, so from letter B to C, so we start with this range, and then we would need to use this one as a sub-range of the previous. It all sounds a bit complicated, doesn't it? So it's probably better to not spend too much time on trying to explain it rather than actually doing it. So this, let's just say this is used as a sub-range of the previous range. Okay, so 0.1 to 0.35, and then 0.35 of that sort of range. So it's like saying, okay, we might have, re-sketch this. That might consider that to be a range, and then the next one along is going to be a sub-range of that. and then the next one is even less than that, isn't it? 0 to 0.1. So we could get away with sort of doing one down there. But then it's going to get quite small, and we might need to zoom in, or similar, which is quite good if we can actually, but not confident that that will work that well. Yeah. So those are smaller and smaller sort of fractions of the original values. Um, so and that can be quite handy. Um, so the range gets smaller and smaller. Oops. So this means that range is okay. Right. So let's start it then. Okay. So for transmit, let's transmit a B. So we've got the transmit B. So we start off with a 0 and a 1. And let's put some lines in here as well to help matters. Just move this along a bit. We've got plenty of space. So how many? We're transmitting 6 symbols. So let's try and fit 6 in. 3, 4, 5, and 6. Okay, uh, so yeah, if we've got 0.1 to 0.35. So the new lower range. So this is the so this is the lower range value. That's the upper one, obviously, rather obviously. Okay, right. So for what we want to do then is we're going to say, okay, new lower range. Is equal to, so we've got 0 plus, and then we we work out the original probability, or the old range, which is 1 minus 0 there. And then we multiply it by the lower range value for the symbol that's being transmitted, which is 0.1 in this case. And that should, for the first symbol, it should just equal that lower range value of 0.1. For the upper one, though, we've got, let's say, new upper range. Similar idea, okay? So we plug in that lower range value, so that is from over there, and we add, and we got this 1 minus 0 again, times, and then the upper value for symbol B, which is 0.35. That's right, Aaron. Yeah, so good point. So this gets repeated until you keep getting these sub-ranges until you've got to the end of the message. And then you get left with a very small sort of um, range of values. Now that is an inherent sort of problem with this, although one that's relatively easily overcome, which we'll see in a little while. So anyway, let's carry on. Let me get to the end of this, and then hopefully it will make sense. Because at the moment it's sort of we're not quite seeing the end of the tunnel, are we yet? So let's work through this, and then hopefully it'll come together in terms of making sense a bit more. Okay, so that's for letter B. So the new lower range is 0.1, and the new upper range value is 0.35. Okay, then for letter C, or symbol C, so that 0.1 gets used in place of these zeros, because that was the one that we had there, wasn't it? Yeah. So we could type this in if we liked. Might make it a bit easier to see what's going on. Okay, so we've got equals, and then we've got so it's 0.1 plus, and then we've got the range from before, which is 0.35 minus 0.1, and that's multiplied by the lower range value for C, which is 0.35. Okay, so whatever that works out to be, I can show you MATLAB, but it's not essential to use MATLAB for this, or the calculator maybe. Or Excel even. Yeah, Excel this is a good one for Excel as well, actually. So if we zoom in a bit, so we got previously we had 0, and previously we had 1. Okay, so for B, we've got the MATLAB starting as well. Hooray! Okay, so we got for B that calculation there, haven't we? So it's taking the previous value, and then we're adding the difference between those two values. But then this is a point where we're bringing in the new range value. So the new range, lower range value for B is a 0.1. Yeah, so I have to do that manually, but that should be okay. Okay, so that's for the lower range value. And then for the upper one, we've got the same sort of calculation, but multiplying by 0.35 for B. So it's equal to that plus, and then the difference between the two, and then multiply by the upper range value for B. So of course it's for the starting symbol is 0.35. Oh, thank you, Ishan. Let's see if Ishan's got the right value now. So for C, what we can do is now, a good thing with Excel, obviously we can repeat the same calculation. Now that's coming at 0.125, but I haven't put in the C range values, have I? So that should be in 0.35 there. Oh, yeah, well done. Thank you, Ashen. And then similar idea for B, for the upper one. But then this one is 0.7, as we can see up here, can't we? So 0.7 for C. And that's coming out 0.275. So we could write that in, couldn't we? Okay, so there it's 0.1875. Now the temptation might be, to round it off. But we don't want to do that. So if we round it off, it's going to remove the information that we actually want to keep. Okay, right. So let's do the same over here, but for the upper values. Okay, so this one was 0.7, wasn't it? And it's coming out to 0.275. Okay, right. So A's next, isn't it? Right, A here. And then over here, we've got a similar calculation to be made. Right, so now this is where it gets a little bit tricky. So we've got the lower value there. That should be 875. And then this is the upper one, isn't it? So 275 there and 1875 there. Okay, and then this one is for letter A, isn't it? Which is a 0. Okay, so that comes to something. Let's do the calculation with Excel. So we've got A. So for A, we're going to need to put in A's value there. A is 0. There we are. Just the same, isn't it? 0.1875. And you'd expect that, wouldn't we? Yeah, it's just starting at 0, so that doesn't modify the lower value, but it will modify the upper one by 0.1, wouldn't it? Yeah, so let's copy that in anyway. So we've got 0.1 there. Okay. And then for letter C, well, let's put those values into the sheet first, to the canvas. So we've got 0.1875 there. And then over here, copy that. Oops. Okay, so we've got the same values except for 0.1 there. So that will come out to what we've got calculated, so 9625. And that gets repeated, doesn't it? Maybe you can do it faster than I am. Should be good. Do you want to have a go if you got access to Excel or something? Right, so next one, 0.187. Yeah, that doesn't change, does it? But this upper one does. So that's 19625. And now this is for letter C, isn't it? Symbol C, rather. So the lower value is 0.35. And then result is, let's work it out. So we have for symbol C 0.35 there. And it's thrilling stuff, isn't it? I'm regretting making the message a bit long, actually. Okay. Check I'm doing the right thing here. Looks right, doesn't it? So we start off there. So it's E3 minus D3, E4 minus D4, and then here, E4 minus, yeah, so that works out. Yeah, okay, and then for the upper one though, and symbol C is 0.7, isn't it? So put a 7, 0.7 there. And it's getting smaller and smaller. Right, so next one is we've got that rating, haven't we? So that's 190563 there. And over here, do the same. No, he's not going to let me. Forgot to do the copy. Right, so it's 1875 plus, and then we've got the previous values 0.19625 minus 0.1875 times, and then the upper value for C, which is 0.7. And that should come out to 0.193625. Okay, right. Symbol D next, isn't it? We're nearly there. B, C, A, C, D, D. D, 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 D. D, 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 D. Okay, so for D, we start with 0.7, don't we? So we need a 7 there. And then this one is a 1. And the 1 means that it stays the same because it's right at the top. And then we could repeat that, couldn't we? So let's do the same. There we go. So that's those are the N2 values. So D there, our calculation here. So here we're adding the lower value, 0.190563 plus 0.193625 minus that lower value of 0.19056. I'm going to run out of space here, aren't I? So times, and then the D is a 0.7, isn't it? So 0.7 there. And then that gives us a value of 0.192706. And how do we do it? No. So we've got that's equal to so same calculations, 0.190563 plus the 0.193625 minus 0.190563, but then this one is multiplied by 1. And hey presto, it comes out to be the same value there, doesn't it? Because it's at the upper range. Okay, the last one is a D there. So sort of do the same thing. So this one is 0.192706 plus, and then those two subtracted. So 193,625 minus 0.192706 times 0.7, which is 0.193949. Oh, this is taking a long time, isn't it? Done very other. Hopefully, it's we got to a point where it's the process, at least for process, is it fairly clear? Can you understand the calculation now? I hope so. What I can do, for the Excel, I'll put that on Moodle as well. And, if you want to have a look, you can just check that out as well. Um, and right, so let's concentrate. So 193 625 minus 0.12706 times 1. And that's just going to be the same as before. Right, so there we have it. We've got a small range of numbers. Move this back. So okay, so this small range corresponds to the, the case of when we want to transmit this sequence of, what was it? It's a BC, wasn't it? B, comma C, comma A, comma C, comma D, comma D, with those particular sort of probabilities. What else? So to transmit the information, the receiver and the receiver would need to know the probabilities, and then the range of values that we have right at the end. So, i.e., it would be any number between, so 0.193349 and 0.193625. So yeah, that's the idea. But how does that how can we do that? It doesn't seem to make sense on its own, does it? We've just got a floating point number. How do we get from that floating point number to bits or something we can actually transmit and things like that? So maybe that's something we can work out. Let's have a break, okay? I'm gonna have my cup of tea and stuff. So let's 10-minute break, and then we will reconvene, and hopefully it will be a good place to stop the video as well, so it's not humongous. And if you've got any questions, then please fire away as well, and we can sort of get back into it in a little while, in a few minutes' time. Okay. Okay. Right. Um, so yeah, this is the calculation in action. It's giving us a range of values that we can use to transmit data at um, a more optimal way, let's say, okay, or in a more generally applicable um, way. So for entropy coding, there was this Huffman coding. So Huffman coding is good, but it's not going to give us as much space-saving ability as maybe some other techniques like this arithmetic coding. Right, so let's go back to the slides. So there's an example, a shorter example where we get a range of values of between 0.76 and 0.79. So yeah, we've got these funny brackets. So the square bracket indicates, you can transmit 0.76, but the round one means that it could be any value, but not including exactly 0.79, something like 0.78999999. Okay, so it's not including that upper value. So how does that work out? Well, there's another example here as well. So that's perhaps one you might be able to follow as well. Um, so what's it saying? Arithmetic coding is not practical for realistic messages because it relies on repeated calculation of fractional amounts, i.e., that number is corresponding to a more greater level of precision and a smaller range of values. And so these repeated calculations result in numbers that cannot be stored or even processed in the unmodified form because computers are not able to represent floating point numbers to infinite precision. Yeah, we just imagine we're looking at transmitting just six symbols, and already we're looking at quite a high level of precision there, uh, at least to what we're used to working with. Computers can work with much greater precision, but still, there's going to be a limit, isn't there? Um, so what can be done? Well, it can be made practical by using integers. Okay, so we may have this concept of working with subranges of a floating point number, but they can actually be mapped to a set of integers. It's also faster as well. Yeah, so integers are good because we're going to say, okay, if we take a subrange of these integers, then once we get to a point where that subrange isn't making any change, we can shift it. We can shift left or right, depending on which way. Shift left, isn't it, on here? Okay. So, and then also, it will be arithmetic on integers as well. So you may or may not remember maybe doing, I don't know, divide by two with binary, but that's simply sort of shifting the bits left, isn't it? I think, or no, that would be shifting them right. But so anyway, that's quite fast, yeah. But then integer arithmetic, it's not probably as quite as fast as that, but that's a similar sort of concept in speeding things up compared to floating point calculations. Or at least it used to be. I mean, floating point calculations are still or can be a lot faster these days. Okay, so this is an example now where um, using integers. Okay, so we've got the upper and lower range, lower and upper range, lower and higher ranges of the numbers to be transmitted, and then may get calculated again and things like that. But what's actually happening here is those values are getting mapped to a range of integer values. So 0.70 or is being mapped to 7,000, and then 1 is being mapped to 9,999, or 10,000 is the upper limit on that. Okay, so for the first symbol to be transmitted in this example, we transmit some numbers between 7,000 and 9,999. Then the letter or symbol B follows, and that's a subrange of the 0.7 to 1 values, isn't it? So, and that gives us, using these probability ranges that we've got up here, 0.76 up to 0.91. In terms of the underlying or mapping to integer values, that's simply 7,600 to 9,099. So that can get repeated, and then eventually we would find that the leftmost digits are no longer changing, so we don't actually need to keep those. Okay, they're the ones that actually get transmitted in the end. But anyway, this example doesn't go that far. But what it says is basically any number between the integer values of 7,600 and 7,899 would correspond to this message of CBA. Here's a more sort of lengthy example where it becomes a little bit more obvious of how the data gets transmitted. So we've got the symbol ranges for the symbols D, A, B, E, and A. So I think this builds on, does it build on the one we had earlier? Yes, yeah, it's the same one as what we got in this example here. We haven't actually gone through this, but this is done basically on the floating point numbers. But then if we look forwards, so we would get the same floating point numbers. But what actually happens is the mapping to the integers is like this. So we get 7,000 to 8,599. Then the next letter to be transmitted, symbol, is giving it's giving us 7,000 to 7,720. And then the next one is 3,240 to 4,175. Oh, how come? That is because the number 7 has been is remaining constant. Can you see that? Yeah, 7,719. So that 7 can get transmitted. So it gets removed, and then a 0 gets added onto the lower number, and then a 9 gets added onto the upper number. Okay, because that's the upper limit, isn't it? And then, so those are the new sub-ranges that are actually being considered there. All right, and then what? Oops, what now? What next? So for the next one, we've got a similar idea there, haven't we? So we're going, but in terms of the range of values, those floating point numbers, or these integers, get mapped back to the floating point numbers. So we've got a range of 0.72 down to 0, or 0 up to 0.72 for that calculation map. Do you remember? So use the upper and the lower limits, and then you multiply by the new sub-range value, and then add back on the lower range value. So when we transmitted the 7 there, we get a new range in terms of integers, but then that also gets reflected back into the floating point numbers. Right, so then what else we've got? So in terms of the integers, then we get a 3240 up to 4175. Right, okay, then transmitting, in terms of calculating for E, that is a subrange of 0.4045 to 0.4128. Yeah. So now we've got 4 in the lower and the upper ranges, so that can get removed. And then we put in a 0 in the lower one and 9 in the upper one. So maybe we can go through. Do you want to try this yourselves? Do you want to have a go with that? Oops, something happened there. Hang on. Right. Yeah, anyway, so do you want to try this? But on the example that we were looking at? Is that a tall order? Shall we go for it ourselves? Shall I go for it? So actually what we can do is we can take these numbers and we got it in Excel, haven't we? Let's have a look in Excel. Oops. Okay, so so yeah, we've got the numbers here, and what else? Well, what we can do is if we multiply these values by, say, it's 10,000 in the example we're looking at, isn't it? So if we multiply them by 10,000, and then we'll get our set of numbers that we need to, and we round it as well, don't we? Yeah. So it's quite. I think it could be quite simple. So let's try it. Let's say, okay, we're going to take, we're going to round it. Well, let's multiply it by 10,000. 1, 2, 3. Multiply by that one. Okay, and then the same for that one. So those are these are the floating point numbers. These are the integer value numbers. Yeah, and we can repeat that, can't we? Oh, well, what happens? Look, we're getting one thing is we're getting values which are basically um, floating point numbers on this side as well, aren't they? So we need to round it off as well. So we need to apply that round function, that MATLAB, that Excel and MATLAB and lots of other. No, what happened there? We need a comma, do we? Yeah, we need to put in the precision there. So we could do it. Do it. There we go. Oh, look. Yeah, so we got a 1,000 to 3,500 there. 1,875 to 2,150. So nothing to transmit there. But at this point we do, don't we? We've got a 1 on the left there, haven't we? Yeah, so the 1 can get transmitted there. And then we'd be left with 875. But then we'd need to put in a 0, wouldn't we? And a 9 on the upper. So it gets it changes a little bit, doesn't it? So we can't just simply sort of adapt this calculation in that way. We can try, but it's not quite as simple as that, is it? Yeah. So let's have a quick look at how that works. So. Probably need to make a new table. So this, let's sort of summarize what we need to say here. This range of numbers can be transmitted using a slightly modified form of the algorithm in terms of integers and left shifts of those integers when the leftmost integer is the same for the current, lower, and upper values in the range. Oh, we got a question. Let's have a look. Good question, Benjamin. Thank you. So, given that we are working with boundaries, do we need to truncate for the upper bound when ending up with floating point after integer conversion and then rounding up for lower bounds? So that's a good question. Let's work through the example and we'll hopefully see how it works. But the point is, when we convert to the integers, let's go back to the slide and maybe that will answer that question. So here we've got the conversion to the integers, haven't we? So these are basically multiplying by that 10,000 limit up, isn't it? But then we are not including the upper that top value, are we? We're subtracting 1 there. Okay, and then when it gets to a point where we say are transmitting, we transmit 7, don't we? And then here we're adding a 0 and then a 9. Okay, so getting rid of that 7, and then um, after the left shift we need to put something, don't we? So we need to put in on the lower bound a 0 and then an upper bound a 9. Now that gets translated to, what does it get translated to? We can see down here a 0.72 for the upper value and then a 0 for the lower value. Yeah, so that kind of looks like, high precision. But then what happens? Okay, so we get more and more precision there, don't we? Yeah, 0.324, and then again, nothing to transmit there. But on this point here, we've got 4045 to 4129. So in terms of the integers, that's 4045 and 4128. Remember, this one multiplied 10,000 minus 1. I've got a common value of 4 there, and then the 4 gets transmitted, and then because of that left shift, we put a 0 and a 9 on there. So it kind of takes care of itself. We don't need to worry about the ever-increasing amount of required precision on the floating point numbers, because there's this sort of duality with the integers. So, when we transmit, that's a point at which we can say, okay, we don't need any more precision than what's required for that range of those, say, integers. So, does that make sense, Ben? Or not? Well, Aaron's got one. What happens if there are 3 repeats of the numbers? Do you just shift the 3 numbers to the left? Oh, good question. So, I haven't thought about that one. Yeah, if you got the same, I'd imagine that wouldn't necessarily happen that often, if at all, would it? Because so what's going to happen is, as you work out calculation for one symbol, if you got, say, 0.111 to 0.1112, one symbol, that's quite a low probability, isn't it? So for transmitting a symbol with that level of precision, perhaps. So it's an interesting suggestion, isn't it? What happens if you've got more than one sort of column and matching? I probably need to get back to you on that. But that would correspond to one of the symbols having very low probability. So yeah, interesting. Thank you. I better write that down, hadn't I? What happens for what happens for low sort of probability where the range is very narrow? Good questions. Well done. So it sounds like you're getting the hang of it. I'll put up a worksheet for this, I think, and let's just go through the example we've got there. So we got, for completeness, say. Um, so we need a new table, don't we, for this? And we're transmitting 6 symbols. Could probably dream up uh, a nice sort of Excel spreadsheet to do this, but then it's going to be requiring some sort of specialized functions and things, isn't it? Okay, so 6 symbols, and on this one, the way it's presented on the slide, at least, we're sort of making quite good use of the the rows and columns. So let's try and repeat that here. So that's 1, 2, 3, 4, 5, 6. 6 symbols for transmission or calculation. And then, yeah, we've got the lower and the upper ones for each one of those. And so, oh, thank you, Oshan. Got some avid Microsoft Paint users here, I see. Let's give it a try. A shift, is it? Oh, thank you very much. That makes life a lot easier, doesn't it? Okay. Right. So, ta-da. Oh, wow. Very nice. Okay. Cute. My life was not complete, but it is now. Here we go. Oh, oh yeah, 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 yeah. Oops. Right. Okay. So similar idea, isn't it? May need to venture on to handwritten things here a bit, but right. So this is following on from. I'll do the same sequence, obviously, and on here we've got a B. Oops. Give it a bit more. So we've got B, C, um, A, C, and then D, D. Um, okay, right, so we're gonna do lower, higher. Okay, so then this is a calculation here. The actual integer values. So integers. This is what's going to be transmitted, and then after integer after transmission. And then we could put in, so that's for the integer, and then I might put in an extra one. So after transmit, we've got the floating point as well. Okay. Right. So B's. it'll make life a bit easier if we can put in the actual values. So let's put in the values for B's and C's and everything. So those there. I might start a new paint as well, perhaps, to help with that. Okay, right, so um, got B of, so this is, originally it's 0.1 up to 0.35. Then we've got not next one for C, it's 3.5 up to 0.7. And then we've got a 0 up to 1 and 0.35 to 0.7 again. And these two are 0.7 up to 1 now. So that's 0.1 obviously. A. So 0.7 to 1. Okay, right, so for B, it's just the same as before, isn't it? You know, for the actual calculation, it's a sub-range 0.1 up to 0.35. Very simple. In terms of the integers, that would be, so we're multiplying by 10,000, so that gives us 1,000 and 3,005. But this is where we need to be careful. This is 3,499, isn't it? So there's nothing to transmit here. And after transmit integers, so this stays just the same. After transmit the floating point values, so that would be just the same as well. So 0.1 to 0.35. Okay, for the lower, then we've got that familiar, hopefully somewhat familiar calculation to do here. So for before we had for B, after, and then we got the C, haven't we? So that came to 0.1875 and 0.275. So multiplying those by 10,000, we get 1,875, and then we get 2,750. So nothing to transmit there and there. On here we got 1,875 still then, 2,750, and the same for the floating point values. For A to transmit, we keep the same lower value. The upper one though, it became 0.19625. Okay, so multiply 10,000, we get 1,875 and 196. And then we subtract 1, don't we? So, so that's point. How do we do this? Okay, so assuming we can round back, that would be 1962 there. Okay, so now we're in a position to transmit for 1. And then, so after that, we're going to shift it, basically. So we're 8750. Then the upper one is 962, and then a 9 there. After transmit floating point numbers, then that would be a similar idea there. So we've got 0.875. And then this one will be 0.9629. Okay, so this is where it departs from what we had before a little bit. Um, so if I do modify calculation, it's probably good to write it out, isn't it? Um, so choose blue. So the upper and lowers, and then we're adding the lower, aren't we? So it's 0.875 plus, and then that range, which is 0.9629 minus 0.875, then the lower value there, 0.35. So that comes out to okay. So we got there's no quick way of doing this. So I'll just type it in as it is. 0.875 plus 0.96. Okay, so that comes out to 0.90577. Okay, and then for the upper one, similar calculation, doesn't it? 875 plus all of that times, and then the upper value is 0.7 there. Okay. Oops. This is yeah. So that's equal to 0.936 and a 5. Oh, we got some questions, Ashan. So we've got 2749 instead of 2750. Oh, good point. Yes, thank you. That's right. Thank you, Ashan. So that should be a 49 there, shouldn't it? 49. But then the floating point one is above that, isn't it? And then Yeah, so that should be the same as before. And then that one, if that was rounded up to 6.3, then taking one off that gives us 6.2. Okay. Yes, yes. So let's round this one as well. So should have an 8 there. 0.058. And then down here we're going to have, let's put this in green. So we've got 99058. And then thank you, Abraham. I think it's okay to round it up. That's another thing. Maybe it's good to double check. But so this one is subtract one, isn't it? So 9364 there. Again, we've got common values there. So 9 and 9, and then we're left with the values there, haven't we? So 5, 0, 5, 8, 0, and then that's going to be 3, 6, 4, 9 there. So in terms of floating point numbers, that's giving us 0.058. And then this one here, you're right actually, and that should be 30, shouldn't it? Actually, yeah, so that should be 30. Okay, so this, hopefully we can work through this. I'll double check it, and maybe we need to sort of iron out a few things. But so 3649, that goes to 0.3650 there. Right. Okay. So actually, if I change that, just check that one. I'm running. Oops. Should be 3 there. So that's 9058. That's good. And this is 6.6 actually. So that should have been a 6 there. And then down here that would have been a 5. And then so we've got 3, 6, 5 in there. So that comes out as 60 there. Okay, right. So next one around, we've got rid of a 9, haven't we? And then these are the new sort of upper and lower limits. So if we so that was for last one was C. Now for D, our upper and lower limits are now modified from our previous set of calculations, of course. And then for D, we've got same idea, same calculations using these new lower and upper values. So 0.058 there. Plus, and then the upper one, which is 0.366 minus the lower one, times then the lower value of 0.7 there. And that gives us 0.2736. And okay, so 0. Same calculation, but then for the upper one, it's a 1, isn't it? So that means that it doesn't actually change from that 0.366 that we've got. So in terms of the integers, so this is 2, 7, 2, 7, 3, 6, and then 3, 6, 6, 0. So nothing to transmit yet, but at this point here, it will be the same then. And then finally, not finally, So same idea, those stay the same. Um, and then we can sort of repeat the calculation. So for what we've got there, so we've got a new lower and upper. Ishan, oh, thank you. Yeah, you're right, actually. Well done. Yep. So that should be a 5-9 there. Q. Okay, good. Right. And then for the final one, we've got the same calculations, 736 plus, and then the upper times the lower for D. And that should be 0.338 and 3. And then for the upper one, we've got the same, but that stays the same to what it is already. Okay, so what we're left with on the integer side of things is something, yeah, a common sort of character there, or digit rather. So we've got 3383 and a 3660. Now we could transmit a 3, but as this is the end of a message, we would need to transmit the whole thing, the whole sequence that's remaining. So we've got 3, and Ishan's going to tell me to make that correction. So I've corrected it again. Thank you. And right, so we got those numbers, and what's left off. So that's the 3830, and this one would be 6599. And in terms of the floating point numbers, that would be 0.383, and that one 0.65. Oh no, 600. Okay, right. So yeah, it's a bit fiddly, isn't it? Um, but it's quite nice because we're getting this sort of system of calculation that, if you could sort of do it on a computer, which is perfectly possible. This is something that should be easily sort of implemented with a few for loops and things. Um, then you've got quite an efficient method of coding. So here, so if this is the end of message, then we would also need to transmit a number in the range of values that's left as well. So put a quick note there to say we if this is the end of the message, then the remaining numbers in the integer range would need to get transmitted as well. So, okay, hopefully that makes sense. Let's go back to the slides then. Yeah. Okay, so it's left with a value of 4500 up to 8199. So the resulting message needs to transmit. To transmit that message, you need to transmit a 7 and a 4 and a 0. So 740, and then some number between 4500 and 8200. So it can be any number between these two numbers, basically. Decoding follows a sort of reverse process. So you start off with initial range of values, and then you do a sort of a reverse calculation based on what the received code is. So that's another sort of little bit fiddly process to follow, but you can work out entropy as well, the number of bits that are needed for the code. So in terms of the number 74045, you can have bits associated with that. So any numbers between those two bits would basically need to be coded in that example with 11 bits. Okay, so I'll put up a worksheet for that. There is a problem in the tutorial for arithmetic coding, but I'll put up a worksheet so that you can compare that with the Huffman coding. And then next week, hopefully, if everything's still okay my end, I'll be able to sort of start on the digital communications, or rather the modulation, digital modulation, and yeah, so I'm trying to sort of get to you about how we might um, tackle the digital modulation sort of laboratory. So I realise it's not going to necessarily be something that all of you can actually do at home or wherever you are. So it should be possible, but you know, maybe it's not the easiest thing to do by yourselves as well. Usually I would sort of go around in my lab and help people and things like that. So I need to work that one out in consultation with Abdul and people. Right, thank you for your support and thanks, everyone for turning up, as it were. Um, and yeah, so stay safe and try and sort of um, have a go with the problems you've got, um, or look back at things. Maybe I need to give a few more problems on this. Maybe nothing too, it doesn't take too long so that people can have a go and reflect on things a little bit. Okay. Any questions before we sign off and stuff?
Cheers, John.
Thank you, Michael. I think it was you, was it? Okay, all right. See you later.